Hello and welcome back. My name is Chelsea Fountain. This is my interactive advanced concept presentation for week 6. And this week we will be discussing nuclear bomb. The objective of the video is the destructiveness of nuclear bombs and how they work. To begin, atomic bombs and hydrogen bombs are similar in that both are nuclear weapons of mass destruction that use nuclear energy, and they are created by human hands. However, the difference is mainly how they explode. To create an explosion, a nuclear weapon needs nuclear energy contained in an atomic release during nuclear reaction and radioactive decay. For example, the atomic bomb, which looks like an elongated round torpedo, but the danger of this weapon is inside where the nuclear explosion happens when certain reactions must occur, and that is a chain reaction of the fission of heavy nuclei. There are heavy metals that make this happen. Uranium-235 is used in nuclear weapons, and it is radioactive. Uranium-235 can provide maximum energy during an atomic bomb explosion, and the contents of this isotope should be at least 80%. If something goes wrong, an alternative to uranium is plutonium with an isotope of 239. This element is rarely found in nature but can be produced artificially. Next, I will discuss how to launch a nuclear bomb. The explosion happens because the mass of fissile material is located in one place called critical mass. When reached, a nuclear decay reaction is formed with the release of energy. To get a powerful explosion, one critical mass is not enough. For a destructive bomb, at least 4 to 5 critical masses of matter is needed. There are different ways to make this happen, but the primary way is called implosive, where all the components for a nuclear reaction are inside, but the critical mass had not been reached. To achieve critical mass, create a guided explosion by placing an explosive outside of the bomb, typically in a small bomb, in order to detonate it. When properly exposed, this will cause the space inside the bomb to shrink towards the center, and the density of the uranium or plutonium increases, and the result is a nuclear explosion. Finally, with the hydrogen bomb, energy is released due to the thermonuclear fusion. An explosive reaction happens inside the charge with help from elements deuterium and tritium, along with other heavier metals. But the main effective substance is lithium hydride, when used as a detonator, causes the release of energy, creating an explosion, an explosive thermonuclear reaction inside of the bomb. The result is a powerful explosion. So we have discussed both the how nuclear bombs happen, the atomic and hydrogen bombs, which are both considered the nuclear weapons, and that you have one form of how the bomb explodes with the atomic bomb versus how one explodes with the hydrogen bomb. And again, that hydrogen bomb uses more of a thermonuclear fusion that requires a detonator to produce that mass explosion. Nuclear bombs are also measured in TNT equivalent, and it is typically expressed in kilotons and megatons. And radiation is one of the biggest factors caused as a result of nuclear reactions. And those 3 types of radiation is alpha, gamma, and beta. So lastly, nuclear weapons are not allowed to be used at any given time. They do not there's not going to be more of a nuclear strike against us anytime soon. So they should not be feared, but they are pretty powerful and pretty interesting how you need them to get that mass explosion. So I hope you enjoyed this presentation. Thank you so much.